Actually, I am Nagesh from Krishna Manepalli. Today I need to explain regarding that how to find two elements such that either sum is closest to 0. Here there is a problem statement. There are the two test cases here, test case 1 and test case 2. With the different inputs, how the output will be reflected based on the inputs. For this one we are taking two test cases. Next is the method 1. Here we are using approach like a brute force approach. In this approach we need to find the parameters, and after that we need to follow the steps which one in that approach. After that we got the results what we need. This is the implementation of the brute force approach. We mention it as a method 1. Here we are assigning a list. After that we are getting the list size by using the len function. Here by using some min function we are gathering that some of the variables in that list. In that we are using the if statement like list size less than 2, then the invalid input. Why? Because we need to sum the list of elements here, so we are mentioning this like. After that, initialization of values. In this way we are doing the execution and sum the minimum list of the list. This is a method 2. In method 1 we are using brute force approach. At the same way, this is another method we are using for to get the output what we need. This is our two pointer approach. Here we are creating a function like find closest sum, and after that we are taking a length n as input. The list is sorted in ascending order using the sort function. First of all, we need to sort the elements in a list using the sort function. The sorting function is important. Why? Because it allows use to pointer approach. Because pointer, we know the pointer concept like when we are pointing the first element. By using the first element we are pointing the another element in the other index. That's why we are using that sort function to sort the elements in an order. After that we are using two pointers, left and right are initialized. Left points to the start and sorted index on the list is index 0. The left pointer points the index 0 element, and the right pointer points out the last element in the sorted list. In that way, by using a while loop and by using some minimal pair values and using some of the functions, some of the built-in functions, we are getting this output what we. After this is the implementation of the method 2. As I mentioned, this is a def function as find closest sum. In this we are using, I mentioned the point like left element, left pointer pointers of the index 0, and the right pointer point out the last index in the list. In that way we are assigning the values here. After that we are using if statement, while loop, because based on this we are performing operations to find out the sum of the such elements. After that we are assigning a list, and we are finding the length of the list by using n and assigning the size in n variable. In that way we are doing this. What are the data structures we are using here? In method 1 and 2, the data structure used in the given input list, it holds the elements for which we need to find the sum closest to 0. Hence, it acts as a primary data structure to store the number. In this problem, how many edges we need to consider? When we get that point, we need to consider the empty list, single element list, and list with the duplicate elements, and list with only negative or positive numbers. These are the 4 edge cases to find the nearest element, nearest sum to 0 in this problem. These are the 4 scenarios we need to observe. Based on this, the output and the procedure we need to change. After that, we need to discuss when we are facing or when we are dealing with any problem. First we need to implement. After that we need to check the time complexity, because based on the time complexity the efficiency of the code will be increases or decreases. So in method 1 the time complexity is big O n cap 2, and in the second method we are getting the complexity as big O of n log n. This is the time complexity we are getting by using methods. After that, we need to calculate space complexity also, because we are dealing with a problem. We need to observe how much space it needs, how much space is used for this method, how much space is affordable. In that way, we need to find with the space complexity. So the space complexity of the code is of method 1 and method 2 is O of big O of 1, big O of 1. This is a constant space complexity for the two methods. After that, evaluation of approach efficiency. After that, we need to find that efficiency approach for the problem. We need to take method 1, method 2. This is the final conclusion. What we need to say, like, the solution provided is fast and efficient for the given problem. It has a time complexity of O, big O of n log n, space complexity of big O of 1, and is well suited for handling large inputs. It optimizes the search for the closest sum by utilizing the two pointers technique after sorting the list.